Hiya folks, the old fossil here. Today's video is about loops and execution control using the little Arduino processors. They come with no operating system. All you get is two prom-burned code blocks and an instruction set. The rest is up to you. This is what you get. The two blocks are setup and loop. Setup run once when you turn the power on. When it finishes, you progress to the loop and it runs over and over again forever. Useful things in the setup are to do a power on self-test. Make sure all the stuff you're going to use is really up and working. Logic and data initialization and clear your arrays and things. But oh, by the way, output disable and enable. It'd be very embarrassing because of transient logic things when the power supplies aren't stable. When you first start up, to pull the gear up when you're sitting on the runway. So after the logic is stable and things are all warmed up and working, then you can enable the important output stages. The thing about the loop is this little processor never sleeps. It operates 16 million times a second over and over and over forever. Now those two basic blocks are very useful and they're wonderful, but suppose you want to do something else. Maybe you only want to do something once, try something out, see if it works. And you don't want to have to restart everything, rerun setup, every time you do a new process. So think about putting two things in the loop. Stuff to do once and stuff to do forever, or what you would do on request. What kind of stuff would you want to do forever? A clock or a serial interface. Basically a way to launch another try after you see how the first one works. In order to do that, two flags would be handy. I call them once and again. So basically you want your software to be structured like this. After the setup finishes and you do the again choice, every time you do again, set it back to 0. So you've done it again. Once is for a block of software that you only want to do once. Once you enter it, reset it once to 0, so you only do it once. Now, if you use integers for the flags instead of Boolean, you can use simple arithmetic on them. Like, for instance, you can set again equal to 10 and execute the again stuff 10 times instead of once. Basically, when you get down to the bottom, the stuff to do forever happens every time, like read the serial input. And when you're ready, reset the flags once or again to go back and rerun the loop. And basically, you do not have to rerun setup every time. This is an example. I have a couple of these little controllers out in my garden monitoring temperatures and pressures and things. If you want to let them run forever, they run for months. The block for do forever has a time element and a get serial command element. So every time through the loop, you update the time and you look for a new serial command. Now, every hour, do is required. Every time the time runs over an hour, do this set of stuff. Make the measurements, store them in the data arrays. And oh, by the way, when you want to dump the output, send a serial command to it that says dump, and it will serial print the output. 168 hours a week for this particular kind of application. An integer data array only requires 400 bytes for 200 numbers. A byte data array only requires 200 bytes. Now the byte data values are only 8 bits long, so they're 0 to 255. But that's plenty adequate for normal things like seconds, minutes, hours, and typical temperatures. They don't go above 255, and humidity measurements and that kind of stuff. So byte arrays are very small and very useful, and you can get a lot of them in even a small processor. Now here's some examples of the do forever stuff, the time and the serial commands. Time is just a little stack of rollover loops. Every time the milliseconds exceeds the old milliseconds by 1,000, you add 1 to seconds. If seconds rolls over 60, you add 1 to minutes. If minutes rolls over, you add 1 to hours. If you want to do something every hour, in the hours loop here, when you update it, set the flag to do the hour stuff. Oh, by the way, Arduino clocks are usually not really very accurate. They're good to a couple of minutes a day, but after a week, you can be an hour off. So what I do is dump the log file to my PC. I wander around the garden with my laptop and a USB cable and issue the dump command, and then in the file properties, the create date has the real PC time, and you can use that to interpolate this approximate time that runs in the Arduino. Now, the serial command is not too hard. You have to define what you want to be some commands. These are the ASCII character codes. If serial's available, and this is the stuff that goes in the do forever part of the loop. If the serial's available, you read the incoming byte, and if the warm filling output is 1, you print it, but you don't want to do that every time. It takes a lot of time. And then if the incoming byte is one of your commands, then you do the stuff for that command. Oh, by the way, the second half of the serial input is serial parse integer. That's very useful. If you send a combined command like A180, the command part comes out as the character A, and the serial parse integer will pull out the following integer, the 180, so that you can have subcommands, or you can set things. You can set again equal 180 if you want to do it 180 times. And then, oh, by the way, do whatever it is you want to do for this command. For instance, dump all the serial arrays to a log file. Now, a word to the wise. If you're going to put in little blocks of codes enabled by a flag, try to keep them separated. Don't let them overlap. Make it clean and clear where the flags get set and where they get cleared, because otherwise the logic can get really messed up. Okay, thanks for watching. See you next time.